Okay, today's lecture, welcome to it. And what we're going to look at is actually what, if you've started doing the configuration file for homework, yeah. Last week, this is the topics under network management, yeah. So the theory part of the practical you have done, okay. Right, so not sure why it's the other way around, but I feel that possibly because this week's practical, we want to start with revision, right? So that's why um, we had a earlier practical for the lecture, yeah. So network management, yeah. All right. So let me just start to record our lecture. Right. So this is our topic, right? So let me quickly check here. All right. So next week's topic is going to start on network design and network troubleshooting, right? So this one, a lot of this basically talking about the commands that you use to configure. So some of you maybe already started on it, all right? So, but for the commands, we'll go quickly, right? Because it seems like this lecture has a lot of slides to cover, but mostly there are commands, yeah, commands. So basically, those commands you can refer to them um, for your practical, yeah. All right, so let's look at the topics. So we got two topics on device discovery. First one with the Cisco discovery protocol, right? And this is the protocol that's being used by Cisco. And the other one is the link layer discovery protocol. And this one is a more open uh, discovery protocol, yeah. So we're going to look at them. They're not much different in functionality, but one is proprietary to Cisco, one is open standard. Next, we're going to look at network time protocol, which is used to synchronize time over the network, short for Ntp, right? So hosts that requires the time are called Ntp client, and they will connect to the Ntp server to get the accurate time, yeah? So you're going to look at that. And then the next one is for network management, yeah? Right? So that's under SNMP, stands for Simple Network Management Protocol. All right. And I think you've encountered syslog before. This is system log. Remember that the AAA one is audit. Yeah. So under audit, what we can do is we basically capture all relevant information into a log. So syslog is as a way to do that, right, in the network. And then after that, we're going to look at router and switch file management. So this one is going inside the router and switch itself, okay, and identifying all the files so you know which file is what, right? And then doing backup or upgrading and so forth, right? And then the iOS image management is regarding the operating system of your switch and routers, right? So again, we can do management on it, such as upgrading and also to backup or restore. All right. So most of the commands, right, that is related is basically in the packet tracer from previous week. Okay. So this is the lecture files that you have to use, right, to refer. So I will check later if I've uploaded. If not, I will upload after this our lecture slides. Yeah. Right. So let's start with device discovery with CDP. Right. As mentioned before, Cisco discovery protocol is Cisco proprietary. Yeah, proprietary to Cisco. Right. So, but most of or all Cisco's products will have this protocol installed. Yeah. Right? So it runs on layer 2. So it's a layer 2 protocol. Okay. So discovery here means that you are able to discover, right, any participating device that participate in discovery, yeah, will be able to discover the capabilities of that particular device, right? So you can see here, it is used to gather information about Cisco devices, all right? So this is not remote kind of information, right? You can see here, only devices that share the same data link will participate, right? So basically, it's advertising to its neighbor. So you can see here the diagram, yeah. Advertisement from one device is to the next device. That means the neighbor of that particular device, right? So the CDP is media and protocol independent. So no matter what kind of media you're using, that means whether wired or wireless, whatever protocol that you're implementing in your network, it can run on top of it. Yeah, so it's protocol independent, and because it's by Cisco, and Cisco usually standardize all their products. Yeah, so it runs on all Cisco devices. Example, routers, switches, and access servers. Right. Right. So when a device is set up to participate using CDP, it will send periodic CDP advertisement, right, to its neighbor, right? So the information that's being shared, what's the type of device that's discovered, the name of that device, number and type of the interfaces. We recall that previously we talked about security, right? And we talk about disabling CDP when we are not sure or we want to protect the knowledge about our devices within our topology, within our network, right? Because it basically allow a potential attacker to know more about your network. It's the first step in order to attack a network is to know the layout of the network, right? But this is unfortunate because, in fact, CDP is very good for network management, right? It's an automatic way for a network administrator to discover the devices within the network, right? Without having to physically visit, right, or follow the physical, connectivity of the network. All right. So this is logical because it runs on software, right? So you don't have to basically, a lot of times when we think about physical location of network devices, they are all over the place. It's very difficult to trace them, so in this way, in fact, you will find out about a particular network device that you may not have seen physically yet, right? So it will be exposed to you as an administrator. Right, so here are some configuration for CDP, right? After configuration, you can also verify. So to find out whether CDP is enabled or not, so you just type show CDP, right? And because CDP is basically just whether you want to enable it or not for that particular device, there are a couple of commands here, right? Whether to switch on or switch off CDP. So if you're not willing to use CDP and you don't want to use CDP, simply add no in front the command to enable CDP. So CDP enable, that means allow CDP to run within that switch or router or that particular device, and to shut it down, CDP, so the CDP doesn't run, just type no CDP enable, right? To enable CDP globally for all supported interface on the device, right? Because it is the interface that is going to share or advertise, to its neighbor. So if you want all of the interface to run CDP, so you type CDP run, right? So you can do this in the global config mode. So config terminal, and then you can type CDP run, right? And CDP can be disabled, right, with very fine granularity, in the sense that you can disable it per interface. So usually, just now we're talking about the security risks, right? So maybe the interface that's connects to the host, right, can be disabled. So that means the switch will not advertise information to host. In that way, the CDP only enable on the interface to the network administrator PC, so it can basically get knowledge about the devices, and between internet and intermediate devices lah, between switch and switch and router to router, right? So here you can type no CDP run on the interface that you don't want it to advertise. Okay, example, interface that links to host. Okay, if you want to disable for all of the interface, of course, you can just type no CDP run. Just put no in front of CDP run, right? And then for troubleshooting, that means you want to find out in particular device whether it's a CDP enabled. So just type show CDP interface and then type in the interface that you want to see, right? And then okay, so this command is available when you have enabled CDP on the network, right? Show CDP neighbors will be used to find out what is the network layout, right? So you can see example output here when you type show CDP neighbors, right? Then you can see here, right? The part here is to indicate to you what is the legend. They're using codes, codes to indicate what device is. So under capability, S means it's switch, and it has IGMP capability. It tells you what platform it is and connected to which local interface, right? And connected to that switch via which port, right? So here you can see there are many devices, right? Routers, switch, remote, transbridge, host, and so on, right? So this is very good for you to discover what is connected to that particular router. Right. So if you want more detail, just append this keyword detail, show CDP neighbors detail, right? So this one will even inform you about the switch S1, right? Our neighbor IP address, which is 192.168.1.2, right? So for example, let's say you want to remote to that particular switch that is connected to that router, and you don't have the IP address. So you go to the router, you just type show CDP neighbors detail. If CDP is on, you can then retrieve that IP address so that you can then do a remote link to that switch, right? So this is one use case, for example, yeah. All right, so in fact, packet tracer, I think, is part of the packet tracer exercises last week. Okay, so if you have not completed, just continue with it. Right, so we move on to the other type of device discovery protocol, which is Lldp. Okay, so basically it's just very similar. It's actually called a link layer discovery protocol, but you can see here as vendor neutral. Right, so vendor neutral here means that it's open. It's open, which means this Lldp is adopted by more device manufacturers, right? So if you're a mixed vendor company, that means your network devices mixed vendor. You don't depend on a particular vendor, for example, like Cisco. Then you have the ability to mix your brand. So you can probably use Lldp, Okay. Right. So Ldp works with enabled device, example routers, switches, and wireless LAN access point. So this protocol is used to advertise its identity and capabilities to other devices, right? And also this one also works at layer 2. So just to get information from layer 2 devices. Right, so next we look at the commands that can be used. Very similar, right? Just that the command is syntax will be a bit maybe different because of the name, right? So to enable, instead of using no or whatever, right? We will use LLDP run, right? LLDP run. Okay, and then if you want to disable, put no LLDP run. Okay, right. So it can be configured on a particular interface, right? And if you guys feel that this one is blocking, let me just move it first, yeah. So you can see better. Right. Okay. Right. Right. So LLDP can be configured on specific interfaces, but LLDP must be configured separately to transmit and receive LLDP packets. Right. To verify whether it's enabled or not, you just type show LLDP command in privilege exec mode. So just now was config terminal to execute the commands. Okay. So for any other commands that is to basically uh, troubleshoot, then you have to do it in the privilege exec mode. Right. So very similar, yeah. Right. Type show LLDP neighbors. You can see slightly different with the content of the legends up here, right? And then the neighbors list down here, right? Neighbor list down here, the legend here to identify, right? So for example, R1 capability R is a router switch, 2 S2 capability B bridge, right? So bridge is another word for switch, and it's actually an older word, right? For switch. Okay, so you can see the age of this LLDP. It's actually still using bridge for switch, right? But it's a switch, yeah? B bridge. Right. So if you want to view information, then you again append the keyword detail, right? And I'll show you a lot more information, right? So you can see the information is shown here. They even tell you this router, yeah, is uh, running what kind of OS, so Cisco iOS software here, and the release, right? So it's good for troubleshooting, yeah. Right. So again, this packet tracer exercises is fine. It's inside your packet tracer exercise from last week. So we move on to NTP, right, which stands for Network Time Protocol. All right. So usually you must have learned earlier on in FCN, right, how to set the clock, right? Set the clock of your network device. So basically, just type clock set and the time with the date, right? And this is the way you set the clock for a particular device, right? So this is very inconvenient as you scale up. That means if your network become large and you have more and more intermediate devices, you have to go, if you do it this way manually, you have to go to each and every one of the devices and basically log in and set the date and time, right? Right. So the other way is to use something called network time protocol. So I want to talk about just show you an example of this network time protocol. Right. So network time protocol basically is a server that runs the time service, right? So that server basically gets its accuracy. Yeah, of course it has to be accurate, right? From an atomic clock, for example, right? So let me just give you a link for that. So if you wish to further read about atomic clock, I'll give you the link. So what is an atomic clock? Atomic clock is basically a very accurate timepiece, okay, timekeeping machinery, right? So you can see that one of the very regular pulse, okay, is when element is radiating, right? So of course it's a bit more complex than that, but I invite you to read, right, about atomic clock. Okay, so what happens is the time server connects to this atomic clock to get its very precise time, date and time, right? And that is the basis of why the time server has a very accurate clock. And then what happens is that the rest of the devices, even computers, yeah, even computers can set their time, right, uh, to be from the time server. And in this way, you can synchronize all the clock on your devices and your host as well. Host also, although here we talk more about our network devices, but our OS also gets its accurate time from the atomic clock, from the time server, right? So why is it important to synchronize all your time? Because remember again, back to the previous example about the triple A, one of it is audit, and that means running syslog. It means logging whatever a user, okay, after being authorized to use the network, whatever a user perform in the network, whatever kind of configuration, then it will be captured and sent to the syslog server, right? So one of the key aspect of logging, right, is timestamp, right? So timestamp identify the precise date and time when an event happened. Okay, so without an accurate time, your logs become inaccurate as well, right? Okay, so uh, and that is why one of the motivation, right, for getting all our devices to have synchronized clock, right? Okay, and sometimes when we do manually set up, we are not very, we maybe not too sure whether our own clock, yeah, is accurate or not, right? So usually when we set up the clock, we use our own clock to set up the time, the date and time, right? So maybe inaccurate plus or minus a few 2 or 3 minutes, right? So here the atomic clock is precise by few milliseconds, maybe a couple milliseconds even, right? So so that's good, right, for synchronization purpose. Okay, so I mentioned earlier on when you're scaling up your network to do manual key in of the date and time is very manual intensive, right? Lots of work, right, and not very easy. Okay, so that's why the solution using network time protocol. This is the protocol whereby the um, client and the server, right? The time client, and time server will both agree on this kind of protocol, right? Okay, so what happens is that the client will connect to the time server or NTP server, right? And then they will then the server will then transfer or forward the time to the time client, Right. So I mentioned earlier on the network time protocol can be used to retrieve, right, the accurate clock from the NTP server, and then you can set up your own. You can have your own NTP server, right? So your NTP server, your own local NTP server, can act as a client, can connect to a remote NTP server, right? But then all your devices will then connect locally to your own NTP server, right? So you can see here, it says that it can be set up to synchronize the private master clock. So your private master clock is the reference clock for your network. So you can choose which one of the device will be the private master clock. Of course, this private master clock will have contacted an NTP server so that its clock is accurate, right? So to avoid all your devices going remotely to that particular NTP server, which is outside your network, then instead of that, they will connect to your configured private master clock. Okay. Right, so the port is using port 123 UDP port. All right, so NTP operation, NTP uses a hierarchical system of time sources. So at stroke, they basically have a level, series of level. The most trusted one is Stratum 0 level. So this is basically the one that's near to the uh, basically implemented using atomic clock. Very accurate. All right. And then as we go down the stratum, right, and then we call that number of hop counts. So from stratum 0 to stratum 1 is 1 hop, 2 hop, 3 hop, 4 hop, and until so on, right? So the maximum hop count is 15. So you can have 15 levels of stratum, right? When you reach level 16, which is the lowest stratum level, right, that device will be set as unsynchronized, right? Okay, so this is the hierarchical nature of NTP networks, right? You can see here we are talking about stratum 0. This is the authoritative time source. So every device will trust this, or everyone trusts this as an authoritative time sources, right? So there are few stratum 0 device that are of clock server. Okay, right. So we assume that this is the standard, right? If you say, oh, which clock is the most accurate, so stratum 0, right? So as you go further, hop by hop, further down from the stratum 0, the trustworthiness of your clock gets lower and lower until when you reach 16, it's not considered at all. It's non-synchronized, right? Okay. Right. So, okay. So before we move on, you can see here how it is. So stratum 0 is the atomic clock. This one, then the direct devices. Stratum 1 could be a network time server here, right? And most clients will connect to devices in stratum 1, and stratum 2 may be the one of the device is a you know it's its own time server, right? Okay, but trustworthiness is lower, right? And as you go down another hierarchy of network time server, another hierarchy of or another level of network time server, then the accuracy may not be trusted as much as the upper level stratum, right? So time servers on the same level or on same stratum level can be configured to act as a peer. So what do you mean by peer? That means they are equal. So if one of the time server is down, the other one can take over because they have some same authority. So if you want to say, what is my backup network time server? Right? So you'll be looking for the peer to your current network time server. Peer as in same stratum level. Then you can trust. All right. All right. So before you configure NTP, if you type show clock, right, at the privilege level, it will show you the current time based on the software clock of that device, right? If you put detail option, show clock detail, the time source, you can see additional info is that user configuration. That simply means that it was this date and time was configured by the network administrator, right? So let's say you enable Ntp server. So you identify the Ntp server by its IP address. So this is how you configure it, right? Ntp server and the IP address of that Ntp server, right? And after you do that, when you type show clock detail again, notice the change from user configuration. Okay, now is NTP, right? So if you want to know whether your time at that particular device comes from where, just type show clock detail. All right. So there are two commands. Yeah. First one is show NTP association, and the second one show NTP status. Right. This enables us to check whether after you enable NTP, to check whether is successful, right? Whether your router, in this case router, right, successfully synchronized with the Ntp server with the IP address that you provided, right? So show Ntp association. So you can see um, R1 is synchronized with Stratum1 Ntp server at this particular IP address, right? And it's synchronized with the GPS clock. Okay. Then if you type show NTP status, it display that R1, because it got its clock from Stratum 1. So the status of R1 is now Stratum 2. Remember the clock hierarchy here, right? So let's say this is your router. It connects to NTP server. This is at Stratum 1, right? Then once you get the clock, your level is Stratum 2. Right? So if you want to set this device to be a network time server as well, you can, right? But its Stratum is 2. So as an administrator, okay, you understand, okay? Stratum 2, the trustworthiness is not same as Stratum 1. So you trust Stratum 1 more than Stratum 2 clock, yeah? Right? So you can see here, show NTP status for R1 is synchronized, so it's successful. Okay, successfully synchronized with the NTP server. So now R1 becomes Stratum 2. Okay, the source of that clock is this NTP server 209.165.200.225, right? And it's at Stratum 1. Okay, right. So Ntp server 192.168.1.1 means this for this particular switch, we enable NTP and we want it to synchronize. We want the switch to synchronize the clock to that FTP server at that address shown here. Right? After you do that, you type show NTP association. Right? So this is private address, so it cannot be Stratum 1. Yeah? Right? Okay. So that means this particular device, okay, that is acting as a local or a private network server, network time server, sorry, right, is now at Stratum 2. So you know that this particular time server got its info, this clock, from this IP address. You can see that it's actually remote, yeah, okay, global. So it should be at stratum 1. That's why 192.168.1.1 is stratum 2, right? So the switch 1, right? Since it is getting its clock information from stratum 2, this switch should be it's a lower level stratum. So you can see as you type show NTP status, clock is synchronized, means it's successfully synchronized with 192.168.1.1, but it is now stratum 3, right? Okay, so 209.165.200.225 is stratum 1. Okay, and 192.168.1.1 got its clock from this stratum 1. So this 192.168.1.1 time server is stratum 2. Since our switch, we say synchronized to that particular time server at stratum 2, that means our switch will be stratum 3. Okay, follow the hierarchy. And so on, yeah, and so on. So any device that uses this switch as the time server will get stratum 4. Right? Any questions so far?
So far, no.
No, thank you, Karen. How about Calvin and Noel?
No.
No, huh?
No.
No. Okay, we proceed. Yeah. All right. So simple network management protocol, or otherwise known as SNMP. This is actually a very old management protocol. Okay. So, but it's got some features that are quite useful, right? So before we continue, let me just give you an example. So I took the liberty of showing you some kind of graphics with that. Wanted to show you something. Right. So why do we want SNMP? What's useful? So have a look at this website. I just basically Google it and very quickly show you guys. Right. So you can see here 12 best SNMP monitoring tools. So the keyword here is monitoring. Okay. So you want to monitor. You want to monitor your network. How do you monitor your network? Basically, a lot of times we want a dashboard where we can see a representation of our network. So maybe you can see it as a topology, yeah? And all your devices, your host link via intermediate devices, and so forth. Basically, the very familiar view that you see in Packet Tracer, but instead of Packet Tracer, it's actually a simulator, so you can play around with creating network and so forth. But the monitoring tools, okay, the software that uses SNMP, basically it shows you something like that, but they are all live, they are all real time. Okay, all your devices through network discovery and also through the SNMP will advertise itself, so you will be able to see, okay, an overall view, okay, of your network. So let me just check out something like this. This is Solarwinds, so you can see as a network administrator having a dashboard like this where you can see all your hosts, all your internet devices, and their health. Okay, their health, maybe and depending on what you want to set with your SNMP client. Later we'll see what is an SNMP client. Basically, each of the device, if they're running SNMP, they will be able to report very detailed information. Okay, more detailed than what CDP can share, right? Advertise. So it could be as detailed as what is your host operating system, what is the RAM, what is the hard disk capacity, and so forth and so on, depending on what you want to capture per client. Okay, I'm talking about host, but it can also be switch and routers, right? So you are doing like a monitoring using dashboard, something like this, right? And in fact, it's easy for you if you have a large network, because monitoring large network, you can't do physically anymore. You simply cannot go around and walk around and check, right? And also checking by, go try to remote into each and every devices, right? It's too time consuming, especially you imagine if you have 50 or hundreds of intermediate devices and hosts, right? You'll be spending the whole day just checking one by one, right? Rather, you want uh, just to show an overall view like this. And sorry about that. That was thunder. It's raining very heavily in my place, right? Rather, you want to see overall view, the health of your devices, your network, right? And you just want to be alerted if there's an exception. Exception, you configure yourself. What do you think is exception? If a device going offline or host going offline or capacity, whatever you're capturing, some capacity has been reached, or something like that, or getting close to it or over it already, your threshold, then an alert will be sent to your station. And basically, if you have a GUI like this, right, and it will update the status, then it's very convenient for you, right? So you can see here, right? You can see here is what you think is more severe that need your attention, right? So there's a lot of network management tools like this, and mostly they make use of SNMP, right? So just give you a context when we talk about SNMP. Yeah. So I just want to give you context on the usage, lah, right? Because later we'll talk about in the technical details of SNMP. We'll just give you context when it's used, how is it used, and for what purpose, right? So a lot of here you can see a lot of dashboard. That's basically right what the network manager or network administrator will look at, right, to monitor the network. So you can see ensure the health of the network, right? So these are some of the monitoring tools. Yeah. All right. So let's continue. Yeah, with SNMP. Right. So you can see here straight away the definition. SNMP was developed to allow administrators to manage nodes on an IP network. So nodes here, we are talking about intermediate devices and also hosts. Hosts also can be installed with SNMP client. Okay, so the client can talk to the SNMP server, right? Right. So SNMP is an application layer protocol. Okay. Contrast that with CDP just now was layer 2 protocol. So this is SNMP. This is an application layer protocol. That means, right, it can negotiate or communicate with the underlying operating system. Okay. Right. To give it more information that is possible at lower layers. If you want to have as much information as possible, example, you want to know, you want even know what is OS version running, how much RAM or how much hard disk space or whatever the available host. But for device similar, what the device can intermediate device can provide. So you can see that it's running as an application layer protocol, right? So it provides message format for communication between its managers and agents. So agents you can think of like clients, okay? SNMP clients, but in their terminology they call it SNMP agents, right? So overall, SNMP system has an SNMP manager. Okay, the manager is where you can basically where all the agents report to. Okay, reports to the manager. And basically, the dashboard you can see just now usually links to this Snmp Manager, right? And the agents are managed node, meaning to say the agents will collect information on what you have set it to collect and store it inside MIB, or Management Information Base. So each node basically will have this MIB, right? Right. So the protocol also talks about how, well, just not just this manage these things, but also manage the protocol for communication or exchange of information, right? So you can see here, right? Defines how management information is exchanged between network management application and management agent, right? Okay, so here we see that one of the way it operates is that the Snmp manager polls the agents, right? Polls the agent mean if you should have more agents than manager. So maybe you have one manager, and if you have 15 devices, then you have 15 agents. If you place an agent at each of the hosts, right? Host on the intermediate device or nodes, right? So what happened is once the agent receives this poll, okay, then it will query its own MIB. So it checks through its MIB, gather all the info, and reply the Snmp Manager, right? Right. So we have this polling, but we also have traps, right? So traps are triggers, right? Triggers, right? If there's any event that you have already specified, okay, I want to trap this event, right? And if that event happens or occur, right? And then the agent will then send that information to Snmp Manager, right? So an Snmp Manager is only one or part of the whole NMS or network management system. It can collect info from an Snmp agent by using the get action, right? And it also can change configuration of an agent by using the set action. So this part of the protocol, the get and set, right? This part of the commands, right? Part of the SNMP protocol commands. Okay, so now that is if you get and you set, it is basically either periodic or ad hoc, right? On demand. But you can set traps, right? I mentioned earlier on set traps. So its trap is a trigger. If an event happens and it's triggered, then it will send or it will forward. Okay, SNMP agent will forward the information on the when something happens lah. Okay, something happens that you want to trap. Okay, so I would say this trap, like I mentioned, is similar to trigger. Okay, you put in some kind of trigger, right? What happens if something happens? Then do something, right? So to do something maybe is to send the information about what is the thing that's triggered to back to the network manager. And if you have very good GUI, example, the trap is to detect maybe the traffic, okay, incoming traffic for that particular agent, right? Is network traffic, right? Is go beyond the threshold that you think that is comfortable. So suddenly, your network management software will maybe highlight that, okay, highlight that info, right? Okay, so we say that the NMS consists of, you can see here, SNMP Manager, agents, and MIB. So the agents and MIB, okay, is at the client device. So that means the MIB stores the client device information. You can see here, MIB store data about the device, and operational statistics are meant to be available to authenticate remote users, right? So the to get the information inside the MIB, okay, it's done by this SNMP agent. Okay, So you can see here the get and set on demand trap when the event is triggered. Okay, when the trap set. Okay. Right. So let's have a look at Snmp operation. So Snmp agent, they reside together with the MIB at the client device, right? So the Snmp agent collect the information and store information about that device and its operation into the local MIB, right? And then if the Snmp manager then wants that information, the Snmp manager will contact that Snmp agent, and the Snmp agent will then query or access the information that's within that MIB, right? Okay, so it's only the local. So there are two inside the inside that device, Snmp agent and MIB, right? So it must be the Snmp agent at that device will connect and collect information from that MIB at that device. All right. So it doesn't work that you're asking one device to go and query about another device. You, as a manager, you need to contact that particular SNMP agent in that particular device to query its own MIB to get info. All right. All right. So, right. So just now we talk about set to set some values, right? Set some configuration values in the device, okay, at that particular device where you send the set to, right? But this set can actually be used to perform an action. So one of the action here example is you may want to restart a router remotely. So you use a SNMP set and you set the setting a configuration that will restart the router, for example. Okay, so other operation from SNMP: get requests, get next request, get bulk requests, get response, and set requests. Right, and the equivalent description here on the right hand side. Right, so when SNMP manager contacted SNMP agent, SNMP agent will respond by doing this, because maybe it's a request from the SNMP manager for a certain value, certain info. So then SNMP agent receive the request, then it will then query, okay, query and to retrieve the MIB variable, right? So the specific request is the get request PDU, right? So this specific request, get request PDU, will trigger the SNMP agent to get a particular MIB variable. Okay, and then of course after retrieving the variable and the content of that, right, the value, then the SNMP agent will reply or response to the network manager, sends it back to fulfill that request. Okay, this is get. Right. The other type of command that the SNMP manager can ask the SNMP agent to do is to set an MIB variable. Right. So the particular function is set request PDU. Right. So what will happen is if the SNMP manager asks to set a particular value of a variable inside the MIB, and if it's authenticated, right, the manager is authenticated with this authorized, then the SNMP agent responded by changing the value of that particular MIB variable. Okay, right. So it might be to change a setting. So part of the MIB variable is basically value is a setting, a particular setting for that particular device, right? So set means it will then change the value or the status of a particular configuration. Okay. Right. So this is I think this is a more generic and also lightweight version of getting information rather than remotely logging into a device, right? So you can see you can achieve it by going into the router and performing all the iOS commands, but this is a more generic and automated way because you don't have to type this command, right? You can have a GUI and you have set, depending on the dashboard or the management software, right? It could be in recurring action that you want to do, right? So that's one thing good about it now. Right. So all right. Before we continue, let me pause for a couple of minutes. Right. All right. I'm back. So you can see that here is actually manually, right? You can get or set a variable, or you can put it recurring. Yeah, if you automate your software to do it for you, right? But sometimes we want to be updated. We don't want to poll because maybe it's we interested in information that is exception to the norm, right? Something that have not normal or abnormal happens, then we want to be informed rather than we ask the agent every time, right? Because it's not the normal thing. So many times we ask, still give us the oh, everything is normal, everything is normal, right? So it kind of use a lot of bandwidth. Not only that, even if you automate lah, you will use a lot of bandwidth. Not only that, it's actually wasting the bandwidth and also the processor time to basically keep asking over and over. So there's another way, or a better way to do that is by setting traps, right? So why traps? Right. So imagine that you have a trap to catch a rat, right? So you don't set the trap and then you keep on looking at the trap, right? You know, if there is the trap catch something, you will hear, right? You will hear that the trap has operated. So and then you go and check, right? Then you can see that it has something inside, and it's not. It's the not the normal thing. That the trap, the normal is it's open, the trap is set, but you know, for some period of time, it may be nothing happening, right? And suddenly, you just one action, the trap has set because of the rat went inside the trap. So it's something like this, right? Okay, the way this the keyword trap is used here. It means it is trapping some exception, right? So that means it says here it's unsolicited because it's not initiated by the Snmp manager. Okay, this message is initiated by the agent, the Snmp agent there at that agent side, at that device, right? And basically, who will set the trap is you, right? As a network manager, you want to know, you want to be alerted if something that you're interested in happens, right? So you set a trap there. right? And for most of the time, maybe nothing happened. But when it does happen, that agent will initiate to send the message. That's why we call it unsolicited, not solicited by Snmp Manager. Basically, it's initiated by the agent because the track is at the agent side. Okay. Right. So again, we do this. This is a better way. It's like the interrupt, in OS, because we don't want to waste the network bandwidth. Because most of the time, as I mentioned before, most of the time nothing happened. Everything is normal. Everything is okay. So if you keep asking regular interval, is wasting or reducing the network bandwidth. Okay, so it's not very efficient, basically. So if it works on a trigger, if something happened, then inform me, like an interrupt method, then it's better, right? Okay, so so you can see that it reduced the polling. The polling is Snmp Manager asking agent at regular interval. Okay, anything happen? No. Anything happen yet? No. Anything happen? No. So that is polling. But instead of Snmp Manager finding out from the agent say, all right, so like this, okay. If anything happen, I will inform you. In the meantime, don't have to ask me. So no polling, right? Okay, no polling lah, right? So you minimize polling. Okay. All right. So example here, it says this example here, SNMP trap is set. Okay, if it detect that one of its interface, which is G00, that means, of course, not this interface, the other interface. Or else, if this interface fell, there's no way the trap can send the message, right? So maybe your track is, I want to find out if this other interface, the outgoing interface of router 1 from me is disconnected or down, right? So the track keep looking at the G00. And if it does go down, the trap is set and the agent will send a message to your workstation, your host, your manager here, right? Right. So the NMS software, network management system software, example just now I showed you guys about 15 of them, right? There are many more. In fact, I feel that maybe Cisco also have their own version. And Solarwinds is one of the more popular ones, right? Solarwinds. I think you can get some of the open source version as well. Right, so I have to check whether Solarwinds is actually open source. It seems, I think it's open source, right? So if you do have a network at home, right, and maybe a couple of computers, one of them is maybe you have your own home server. I think it's a good idea, right, to just play around with it and try to, just to monitor your own network at home, right? Because SNMP is an open protocol, so you can get it and you can install it, right? No problem. But I think your device, if your device is all in one, I don't think it supports, unless your home device, intermediate device like switch and router, if you have a router, is more capable, then perhaps there's a built-in SNMP agent inside, right? But most cheap ones do not have that. Okay. Right. So you say here, turn the router icon red. So this was one of the examples I've shown you. You can view your entire network, right? So you set all the traps there. Any one of them exhibiting something that you want to know about, you can set the NMS software to, okay, the icon, the GUI, turn red, turn yellow. Yellow maybe, green maybe is okay. Yellow maybe is informational. It's something that you have to watch out. And then red is something that you have to do something about. For example, right? Okay, so let's look at the versions. Okay, now we have reached, I think, version 3, right? So you can see the request for comments documents here. So this request for comments, whenever you see this, you can search online. This request for comments usually for open source systems, yeah. So that means SNMP's open protocol, so that you can see a request for comments. Usually, if they want to change something or they want to declare how they implemented or about the technical content of the SNMP, whichever version, right? They will publish it first, and then they will request for comments. Okay, that's how the open standard works. Okay, they don't simply implement; they will publish it, then request for comments and see what people who use that protocol uh, um, will say lah about it, will comment about it, whether there's any changes or whether they're happy with it, something like that. So request for comments, you can basically check it out for further reading if you want. All right. So of course, from version 1 to 2 to 3, the last time we used, I think, is version 1 and 2. Right, it's now version 3. They keep improving the protocol. Okay, last time you're just using a simple community string based authentication method. Community means one authentication for all, right? Okay, so if it's compromised, then everything compromised. Okay, so not so good in terms of security. But at that time, you can see its legacy. At that time, it was okay right? But now, simply too insecure. Then we have version 2. Okay, still use simple community authentication method, but it enhances the capability, right? For example, now provides for bulk retrieval options, right? And then version 3 now improves security, uses username authentication. That means you can configure not in general authentication anymore. Community simply means one password or one authentication for all, right? So here it's more targeted, right? So you can then be sure if one is compromised, the rest still okay, right? There is a password. If I know one password, but that's likely for just one particular agent, then it's all right. Okay, all right. So introduction of more secure hashing method and also encryption. So you can see AES is actually quite secure, the encryption. So not easy to reverse engineer or to brute force attack it. All right, so you can see that version 1 and 2 still use community strings, not only for authentication, okay, but everything is not encrypted, no encryption. Only version 3 start to get encryption. These are encryption algorithms, AES in 256-bit or 128-bit encryption, quite secure. But last time it's plain text. So if you do a man-in-the-middle attack, that means if you sniff the SNMP PDU, you can, and then you can see the password because it's in plain text, it's not encrypted. Okay, so that means what is this authentication for? In order to be able to access the MIB objects of that particular device. And this is crucial because remember, reconnaissance is one of the reconnaissance is one of the first thing that the attacker will do, okay, to find out in more depth about your systems, your network or your devices, right? So if they have access to MIB objects, depending on what was stored in MIB object, and usually it's a lot of info about that particular device, then they may find some, you know, some way to attack that particular system, or use that particular system, which is not vulnerable, to attack the rest of the devices on your network, right? So it's very important, this control. Okay, so community means once I access this particular MIB object, I may be able to use the same you know password to other MIB objects as well. All right, so commit string, we got two authorization. One is read only or RO, and one is read write or RW. So it's self-explanation. Read only means you can only view the info inside the MIB objects. Read write permission means you can view and alter, okay, change the value of those MIB objects. Okay. Right. So how is it stored inside the MIB? Okay. So it's stored hierarchically. Variables here means the variable name and its value. They are stored hierarchically, right? So MIB defines each variable as an object ID. The OID uniquely identify the objects as being managed inside the MIB, right? So the way it organizes these OIDs are based on request for comment standard. So it's a standard, right? So if you want to implement MIB for SNMP, that means you have to follow because it has a standard, then you have to follow that way. Okay, which is hierarchy of OIDs, and usually this hierarchy is represented by a tree. So basically, like the hierarchical organization chart lah. If you ever seen one, then you know what I mean, right? In the next slide, you can see an example of the structure. Okay, structure of the hierarchical structure. Right. So there will be some common public variables, right? And then you can see actually by category. So if the variable is a top level, means it's more common, right? So it basically a lot of devices share the same variable name or variable value to store, right? Then as it goes down the tree, then it becomes more specific, more and more specific to that particular device, meaning that variable value pair would be maybe even unique to that particular device. Other device may not have that. So you can find those as you go down the tree, you'll find that it becomes more specific until you reach the bottom of the tree, the root. Then you'll see that, no, sorry, not the leaves of the tree. Then you'll see that it will be very highly specific to that particular device. Right, so let's have a look here, right? So Cisco defines the MIB in this manner, right? The structure of MIB. So you can see it's still hierarchical, right? Top hierarchy here, and you're going to go down the levels until here are the leaves of your tree. The root of your tree is usually on top, right? Okay, so it's an upside down tree, basically. All right, so note how the OID can be described in words or numbers to help locate a particular variable in the tree. So OID belonging to Cisco's are ISO.org, DoD, Internet, Private, Enterprises, Cisco. Right, and then got local variables, this group, Cisco management, and so on. Okay, so that means OID is, the hierarchy is 1361419. 1361419. All right. Okay, so we talked about traps earlier on. So we come back to polling, right? So here, right, we use it. For example, this is an example. One of the things that you can observe is CPU utilization, right? So in fact, it is so detailed because it's an application level. You can retrieve from the OS the CPU utilization. Utilization means how's the CPU user. So if you're in Windows, you can just go to Task Manager. You can look at the processor, right? And you can see the processor utilization, right? Or CPU utilization, right? And if you keep getting the at every snapshot, you take one one value, that particular value for that particular time for that CPU utilization, you can actually plot a graph, right? So you can see the CPU utilization go up or down or stay constant over a period of time. So depending on how long you want to monitor the CPU utilization, you can set it like not ending, so you can keep on seeing it lah, right? So exactly as you imagine, how Task Manager shows you the CPU utilization graph inside it, right, to monitor the resource. Okay. Right. So it says please create a baseline. So at least you as an administrator, okay, as when you compile over a period of time, you can see the average, right? You can then calculate the average. Well, it depends on your dashboard, right? Because over a period of time, you can see the what is the highest peak of CPU utilization for that particular device, what is the lowest peak, and what is the average, right? And you can basically do this for if you go over 24 hours, over 7 days a week, over 30, 31st, 31 days in a month. You by compiling this in four, you can basically know when is the peak time of CPU utilization for that particular device. Right, so this may be useful for long-term or even short-term monitoring. Right. So how do you get this data? By using the Snmp get utility issued on your network monitoring station. So using the Snmp get, you can manually retrieve. So this polling, right? So basically the manager contacts the agent by using this Snmp get the information they required. In this example, CPU utilization, right? So again, you can see here, this report could give you a period of time that you use the data to get the average. So you can see to get the average is usually a baseline. So why is it important to have a baseline? Because if you get a report that your user saying that, oh, you know what, my device, my computer, okay, is saturated, is using so much, then you know, when you check, right, and it gives you a particular value at that particular time. Then if you have an average and that is your baseline, you can then see how high is the utilization at that particular moment compared to the average, right, that you've been collecting, right? So it could very well be network utilization or network traffic, okay, coming in and out of their interface, right? So even though sometimes I give example about host, this applies the same to other devices like switches and routers, right? Depending what you set, what that device is capable to show you, and what is the agent able to store in the MIB, that you can always request. Okay, and if you and just now we said that polling is wasting time, right? So we use trap, but trap can only give you abnormal readings, right? If you want to establish a baseline, meaning what is the average, what is lowest, what is the highest, what's the peak, right? You have to collect your data over time, right? The only way to do that is to poll the same device over and over at all times, collecting and storing that information and plotting it over the period, right? And then you can then perform all sort of calculation on it, right? Whether you're going to get min, max, or average. Okay, you can even, because it usually comes with a timestamp, you can even see where is it that is really high usage, low usage, or average usage at what particular time of the day, particular day of the week, right? So that's interesting. That is very good in terms of long-term monitoring, and also to get ready, right, to upgrade your network before it becomes saturated, before it becomes it cannot handle. Before it cannot handle traffic or whatever. So you can preempt. You can already see the trend. You can then plan to upgrade. Okay, before it becomes worse. Right. So SNMP Object Navigator. So we have this SNMP. This one, Object Navigator, is by Cisco, this software. Right. So you can see here the SNMP Navigator is basically like I would imagine. It's a way for you to be able to query. Okay. Not sure whether it shows you a dashboard or not. I haven't used this, but I think it's a way for you to query a particular agent. Right, so you can try to see whether it's downloadable, it's free or not. Try SNMP Navigator, but it doesn't work if you don't configure an SNMP agent. It has to have agents that store the info in MIB so that you can connect to it, and then it can tell you the information, right? In fact, of course, it's overkill for very few number of agents lah. Actually, but it's become invaluable when you scale up, when you have a lot of devices, switch routers and devices. Okay. All right. So any question on this section?
No.
No.
No, thank you. Noel? Okay. Any question, Noel?
No.
Well, it was just now. Kelvin? Any question? Kelvin?
Oh, I put in chat, no. Yeah.
Okay, no, okay, so straightforward, SNMP, yeah, because we are moving on to the the audit part of the AAA, which is the Syslog, system logging, yeah. Right. So here in this diagram here, you can see Syslog server, and then we have a router and a switch, and you can see the arrow pointing, right? So here, router is basically sending information or system messages to the Syslog server, and switch as well, right? So why do we need the system messages? Because one, we need it for audit, maybe, right? Or two, we want to know more details, right? Or whatever happens, we want to know about it, because the log usually tell us, right? And it's very informative. It tells us what's going on, right? So a lot of the configuration you do is will be acknowledged by the device, yeah. So when you type some command, the router or switch will acknowledge that you have typed that command a lot of times, yeah. It will send some string of text onto your console, onto your command line, right? And these are the system log basically. And if you don't store it somewhere, that log, that information that was spewed out by the iOS, right, will be lost, right? So syslog is a way for you to keep those messages safe, right? You then not only you see it on your console, you will send it over to the Syslog server, and the Syslog server will store it for you, so you can go back to retrieve and view, right? Right? And some of these messages is due to what event is happening at that device, and you may not be there to observe, and you could just get lost, right? So again, all right, it's an efficient way for you to find out what's going on with any of the device in the network if you set the Syslog, so that you can go in and check. You can even, maybe there's a timestamp, you can even like filter to a particular date time. Right. So Syslog login service provides three primary functions as follows. You can get a logging information, and you will use this for not only for monitoring but also troubleshooting. Troubleshooting because maybe you've set the commands, there's a typo, you're not sure you're not aware that you made a mistake. So by going through the logs, you can see. Excuse me, I just get some water first. Give me about 3 minutes. All right, thank you for your patience. All right, so we continue, yeah? Right, so the ability to gather logging information. So I want to say that if you use Linux before, um, that OS also keep logs. Windows also keep logs, right? Windows keep it, and then in order to view, you can view its event, right? Event, and then you can see it's categorized, right? So network devices also have this kind of information, right? In response to if you're doing some commands, right, to configure the device, it will normally show some response, or even if you type commands, uh, obviously if those are configuration or verification, right, then you can see some commands. So whatever come out of the on the console, right, standard output, we see it. Then it can be, if you set the syslog logging, it will be sent to the syslog server, and it will get there, right, for you to review, right, later. Right, so you can select the type of logging information that is captured. Maybe not all of the information you want to log, because some of them are trivial, maybe, right? So maybe you want certain types of logs only, right? And you can also specify, right? If you capture those logs, where do you want it to be sent to, right? So you can specify destination of the captured syslog messages, right? As I mentioned before, uh, uh, you can see that debug output. Some commands you can set verbose or put detail, means it can provide more output for you. And sometimes you do want to keep it. You want to keep all the output for later, right? Now, I think the setting here, right, is ideal, right? Because you have a specific server, right? That is a syslog server, which means it can accept logs from various different devices, right? So in that way, you can ensure that you can identify the log belong to which device, and along with the timestamp, right? Okay, so we don't just send to syslog. Actually, we can see that there are, various type of output destination for syslog, right? So logging buffer, RAM inside the router or switch. Okay, so console line where you are typing. It could be a terminal line where you're remoting, right? And finally, the syslog server, right, that we are talking about, right? All these other three, okay, potential that you might lose the information. right? But most secure storage for your system log is here in the Syslog server. All right, so Cisco device have a lot of messages coming up, okay? Because managing network device actually, and also things that can happen or events happening within a network device is actually, there's a lot of things, right? So providing a way to inform, right? Inform, because these log messages are actually meant for this network administrator, okay? It's not meant for the device itself. It's for human consumption, right? And every log system, okay, the good ones, they always have a category, okay? Whether it's just normal informational messages or it's reporting the severity of the what is happening, right? So you can see severity level. So different level, different severity means different actions that you can decide to take, right? Right. So you can see here in this table, okay, other severity name and then severity level, and level 0 is the worst, right? So because system unusable means basically the system stop functioning properly already, right? So here debugging just verbose a bit, and instead of just debugging is when you want to troubleshoot. There are certain information that may not be suitable for normal everyday usage, okay, but maybe more suitable because quite some of the information are quite esoteric, yeah, means it's not normal messages, yeah, only maybe useful if you are hunting for a particular problem or issue, right? So debugging level 7, debugging message, not so, not so important, right? And then you have informational. Informational means for your info. So again, not that critical, right? Then the next level is notification, right? So it's notifying you so that you're alert about it, but you can decide not to take action, right? But you start to notice really got some info there. Warning, this one tells you you should do something about it already, okay? It's a warning. It's not affecting the operation of the device, but there's some problem, right? Error means some level of the device, you know, ability to do what's supposed to do is what already, yeah? It cannot do already. So there's an error already happening. So this one definitely you need to take action. You need to identify and start to take action already. Critical is well, basically they're all leading towards emergency. So minimal error, more errors happening, definitely, okay, dangerous level, and so alert, do something already, cannot wait. And then emergency, that's it lah. I don't think this one you can do much already, but you may want to read what caused the emergency. If the syslog has some information about this emergency, that you might want to read it to basically find out, right, what happened. All right. Okay. The In addition to displaying the severity, the syslog message also have information facility, right? So it can tell you what service, because it has service identifier. So it can identify services for that particular device and categorize for that particular service what is the system state, right? System state, whether it's normal or there's an error or whatever, whatever happening for that particular service, right? So some common message facility, if you want to check for Cisco routers on IP, OSPF protocol, the operating system itself, IPsec, and interface configuration, right? Okay, so by default, if you don't change anything, then the format is shown here. First of all, what is the facility? So you will look at the facility, like what type, what the category, and then severity level 0 to whatever level just now, 7, right? 0 to 7, right? And then mnemonic is just a symbol to represent, right? To represent whatever it is it's supposed to represent, right? And then some description, right? So some of the messages that you've seen already, if you understand the way it's formatted, you will start to be able to read, okay, the output that is coming out whenever you type command and something happen, then you will see, right? So here, example, link is a facility, and 3 is severity, so error, right? There's an error there, right? Link 3 up down, interface port channel 1, right? And then this is the mnemonic basically, and then change state to up, right? So level 3 severity is 3, although it's not error, but it's telling you that the state has changed, right? So at least you're aware, okay, that after your configuration, perhaps you change the state is down, change to up. It may not be your intention, right? Okay, so it's a way to inform you. Right? Okay, so by default, log messages are not timestamped, right? But if in order to make it useful, you should have it timestamped, right? So when you look at it later, right, you will know when was it, created lah. When was the log created? So at least you have a footprint of what happened. Okay, footprint of what happened based on the timestamp. Sometimes it's good to see the timeline of things happening, right? Okay, so the command to configure that is service timestamp log date time, right? So that means when you do this, it is forced to include the date and the time, right? So if you're not sending to syslog, that means you have no intention to keep the logs, right? Then you might not really want this, because you already know what time, date and time you type the command, for example, right? If you're interacting with it directly, right? But sometimes you're not interacting, or even if you are interacting and you want to keep a log of it, then you want to have just that date and time to let you know later. Okay, when did you change, or if you're not interacting with it, when did this this link went down, something like that, right? Okay, so date and time is crucial for that. Right, so let's have a look at router and switch file maintenance. Right, so here we see that about file system, you can see that if you're inside the real hardware, you can actually change. I think the packet tracer version also, you can change directory. I think they simulate the directory in the iOS also. Right, so as an administrator, you can create folders. Basically, it's just command line similar to an OS command line, where you can manage the directories and files, basically, right? So you want to see the content similar to type directory, a dir in Windows, or ls listing in Unix. In iOS, you type show file systems. I'll tell you what available in the file system. Okay, for example, here is in our router Cisco 4221. When you type show file system, you can see the files and the size. Or okay, sorry, this one all the file system, not the files. File system, temp.sys, boot flash, USB, web UI, and so on and so on and so on. Right? Of course, some of them are network file systems. That means you are accessing network, right? So there are no sizes shown, right? So those that has physical storage size, they will see that, right? Can tell you the size and how much is free. So minus free from size, you get the usage. All right. If you notice this, it's very similar to the way Linux handle its file system, right? Because the RAM is also included, and VRAM, a non-volatile RAM, is also included there. And then you see that they have the network also considered as part of the file system, right? So to me, it's indicative of maybe this OS was initially a Linux kernel, right? So maybe you can find out, right? What's the origin of iOS operating system? Anyway, show file system show you all the file systems available in that device. In this example, in that router, right? Okay, so just now I talked about the common commands to list out the folders or directories and the content, which is directory or dir for short. Right, so I think we are used to this because our OS also, if you go to command line, you type dir, it will also show us. Yeah. Now, another clue that this is actually based on Linux is that the permission here is either drwx. Okay, D stands for directory, R for read, W write, and X execute. Right. So very similar to Linux OS. And then the file size, the timestamp, and the file itself. And usually in Linux, any file preceded with a dot is hidden, right? It's normally hidden, right? Okay, so this is, like it says here, if you type the dir at the router, the default file system is the flash. So it show you the contents of the flash, even though you have multiple different file system, default is the flash drive. So we type that dir from the privilege mode, straight away this out, the content of flash. Right? So it says here, specific interest is the last listing, which is this one, universal K9, etc., VIN or binary, right? So that is the Cisco iOS file image that is currently running in RAM, right? So it means, of course, this will be loaded into RAM first from the flash drive. But you can see there's only one here. This is the one. So this is the image. Whenever the router is booted up, right, then it will load this into RAM. Okay, and that is your iOS. That's your operating system for this device. Right, so we know that's also NVRAM or non-volatile RAM. So in order so that if you type directory, it doesn't show flash, it shows the content of the NVRAM. So you need to change directory, right? Or CD, short for change directory, into NVRAM. And when you're in NVRAM, you can then type dir. The PWD, right, is to show the current working directory. That means which directory am I now in, right? So slash usually is root. Okay, so root, yeah. Okay, yeah. Since we already changed to NVRAM, we are in the root folder of NVRAM or root directory, right? PWD tells us which directory are we in now. So PWD stands for print working directory. Working directory is where you are in now. So If we type dir, you're basically listing out all the files at the root directory of NVRAM storage. So NVRAM is non-volatile RAM. Huh? So that means when you switch off your router, whatever is inside here is permanent. It will not be erased. Okay. Right. So over here, I want to mention last time we keep talking about startup config, right? Startup config, save to startup config. By default, there's none, right? And then if you save running config to startup config, then this file will be created. Okay. So what is this? This is the configuration as when you save the running config. The running config means what is current configuration of this particular, let's say, router. Okay. So what is the important startup configuration file? If you reboot your router or your switch, okay, the system, if iOS sees that there's a startup configuration file, it will load that. Instead of the default configuration, it will load that startup configuration file instead. So it's a way for you to persist your configuration between one session to the other session. Between it, there's a reboot, right? A restart of the device. It will be permanent, right? If you save it to a startup configuration file, then in the next, boot up of your device, you'll get the same configuration. Okay. So if you don't want the startup configuration, so you want to revert back, that's where you delete the startup configuration file. Okay. And then this is Cisco 2960 flash, right? You can copy config file, you can archive, upload, and download software images, right? Is for this model and above, I guess, right? Below this, maybe you can't do that. That's why they highlighted 2960, right? And similar, the commands to show the content is show file system. So all these are file system within Cisco 2960. All right, so use a text file to backup a configuration. Now, this one is Terratum. Terratum basically is one of the more popular telnet or terminal emulation software running in Windows, right? So in Terratum, there's a function where you go to click the file, you can select log, and then you click that, you will save the file. You choose where the Terratum software will save. Okay, we save the text. It will capture the text and save it to the file that you specify as a log. Right. So after the capture has started, that means it start capturing the console. Yeah, Terratum is doing that for you. Even if you're not doing syslog, yeah, this one is done. Especially good when you're doing configuration and you are remotely connecting and you choose to use Terratum. Then whatever you type, if you start capturing, it will capture and store to the file you specify in log. So if you type, like, for example, show running config or show startup config, then whatever text that is displayed by your device will then be captured by Terratum, right? Because the console belongs, it's an emulator of the console in your switch or router. Okay, so Terratum is emulating it for you. So Terratum has control over the display of the text inside that console in Terratum. So it has the capability to capture those texts and automatically save to a log file that you specify. Right. So when you close Terratum, when the capture is complete, when you stop already, you don't want to record anymore, then you select close in the Terratum long window, and then it's actually the file now exists in your local file system, in your Windows local file system. Then it's a text file, so you can just open it with any text viewer or editor to see the content, right? So this is useful if you want to capture what you're doing in configuration, right? Now this one is work for the real hardware because you're running Terratum as a real software inside Windows. Okay, so a configuration can be copied from a file, then directly pasted to a device, right? So this is what I was encouraging you guys, right? You can type your configuration into in any text editor, and you copy, select all, copy, and then paste it into the console, right? And it will be interpreted as if you type the command one by one. Okay. All right. So again, Terratum has features lah. You can read here features of Terratum terminal emulator. Let me just very quickly show you Terratum. All right, so Terratum. Yeah, maybe I go to Wikipedia. You can download Terratum open source project. I think it's in Git. Is it? Let me see. That's the end. Just view the image lah. But you can download it. It's a lot of source. So I think this is one of the screenshot how it looks like. So we have a terminal. It's basically just a terminal emulator lah, I guess. Okay. All right. Let's go to the next slide. All right. So this method is to use TFTP. TFTP should be only used in LAN, because in LAN your network connection is stable, so not really need to use TCP for your FTP. So TFTP is using UDP. Okay, it's fine, right? Because network in local area network is stable. So TFTP basically is running UDP transport protocol rather than TCP, right? So here's a step, okay, to back up the running configuration of your device into a TFTP server. So basically, just download the TFTP server and run it in a computer somewhere in your network, right? In your LAN, right? And take note of that computer's IP address, okay? Because your TFTP server service or software is running there, right? So step one, copy running config TFTP command, right? And then you will start to ask, what is the address of the remote host? You typed it here. So I think last week we've already done this, Kelvin, remember? Last question about this kind, right? So just click enter after entering the IP address, and basically you can take the name lah, but sometimes you want to rename it so that it indicates the name indicates the date, right? Sometimes better. And press confirm, then it will perform the transfer and save, and then once finished, it's like okay, right? Right. So the reverse of that is to restore. So restore from TFTP server. Okay. So you just reverse it. Now the backup is copy source, which is running config, to destination TFTP. So if you want to reverse it, that means from TFTP to running config, just reverse it, copy TFTP running config. Again, it will ask you for the IP address. Type the IP address, press enter. If you want to change the name or not, up to you. Press enter, right? Okay. All right, so if you notice, I don't think you noticed because you haven't looked at the real hardware. Sorry about that. But if I think pretty sure next week our lab should be okay, and there are already Cisco hardware. Not we are waiting for some sockets to the back to be installed, but we can take it out and have a look, right, in your hands, right? So if you look at the back, there's a USB port, right? So the USB port is where you can plug in a USB flash drive, right? So it's like an external driver if you insert there. So you can see the USB flash feature provides an optional secondary storage capability and additional boot device, right? So that means it can recognize a USB flash drive there. Insert. All right. So using USB to backup and restore. Let's say you don't want to use the network. You want to physically manually go to the switch or router, plug in the USB flash drive at the back, or pen drive, we call it, and then copy, right? But instead of TFTP, you give it a name USB flash 0. Very simple, right? And also the opposite is just to put USB flash 0 in front, then put config, running config. Okay, so just switch over the names of the storage. Okay, source and destination, whether you want backup or restore. Okay, all right. So here in this one is password recovery procedure. I think there was a question about this in our previous packet tracer. So okay, so one of the basic configuration that you have to do is to put password, right? So we want to prevent unauthorized access. Okay, and not only that, we don't want plain text. We also encrypt those passwords while using enable secret passwords command, right? All right, so after recovery, passwords must be replaced. Okay, because after recovery, password is missing. It will be gone. So you have to redo the configuration for the password, right? So password recovery is when you don't remember. Basically, you did a typo, and I'm not sure which typo you did, and also maybe you forgot your password, right? So first step is to enter ROM1 mode here, right? With console access, you can access ROM1 mode by using a break sequence during the boot up process or removing external flash memory when the device is powered off. So these two during boot up, okay, with console access, when it's booting up, you break the sequence. Yeah, so you say it will be in Roman because boot aborted due to user interrupt. Okay, so enter that mode, change the configuration register, copy the startup config to the running config, change the password, save again, reload the device. So here is changing the configuration register. Okay, so this is the command. Let's like a magic number, right? Config, okay, configuration register, and the number is actually X is hex 2142. Press enter and then reset. Okay, reset will restart your device. Okay, all right. And then after that, you copy your startup config into running config, right? When you ask for the name, just press enter, right? Because you already put running config there. Change your password by typing your normal configuration like configure terminal, enable secret Cisco, right? Of course, it says example, right? Cisco is not very secure. All right. And then save the running config and startup config, right? After the new passwords are configured, you can change the configuration register back to 2102. So is there a difference? You can see there's a difference. This one is 2142. So 2102. You can see, changing mode, changing mode. The mode 2142 allow you to change the password. Now, the thing is, before you think, oh, this is what, normally your switches and routers should be in a secure room. So if it's a secure room, attacker have to able to break into the room before they can do this stuff, right? Okay. Any question?
No. No.
So we see as 307. So let's go for a break before I want to continue, because next week we have other slides again. After we finish this, then we continue with tutorial. But we take a break first because I think we are already going to 2 hours. Yeah. So we'll take a 10 minutes break. Is that okay?
Okay.
Okay.
Okay. 10 minutes break. So now is 307. Means 317. Yeah. Hello, welcome back.
Hello.
All right, so we continue, yeah. So again, Terratum. Basically now, these slides are using Terratum, but another one that is popular is let me just get terminal emulator. There are many terminal emulator available. Okay, it gets important if you're doing on real hardware. Okay, all right, so terminal. Right. So you can see that. Let me just share with you my screen. Right. So there are many. Yeah. So the one that we are actually looking at in our slides are the Terratum, right? So I noticed last time. I don't know about now, lah, right? Last time in main campus, okay, they use Putty as well. Right? Putty, very simplistic, but quite fast lah. Because I believe not much feature, but still okay lah, right? So you can see it supports telnet, secure copy, login and SSH. So if you're using telnet, you can, or you enable SSH in your devices, also can lah, right? And basically, I like this Emu because it has modern features lah, right? Okay, so that's why I kind of like it. But actually, it's just you know running on top of the terminal, right? So you can immediately run terminal within command prompt, right? And then you get a nice what lah, GUI lah, right? Commander, again, I like because of the modern features, right? But they are just the GUI, yeah. So it runs. So that means your terminal emulator software you install first and then run Commander, and Commander will include that the terminal emulator as part of its config, and then you can have nice fonts and more modern fonts and stuff like that, right? So I think that's why it's one of the top one lah, right? Compared to like Putty, obviously it shows it's what lah, right? It's very basic lah in terms of GUI. Okay, but whichever you use, right, it's up to you, right? Here we use Terratum. Okay, I'm just emphasizing that even though we mentioned Terratum here, right, it's not the only terminal emulator that you can use. It's just one of the available ones. All right. Okay. So Terratum, basically, before you start using any terminal emulator software, at the beginning, if your switch and router are not configured at all, I'm talking about hardware, you need to connect to it using console first, console cable, right? So in the real world or in the hardware lab environment, what you need to do is connect the console cable to the back of the device and connect the console cable to the back of your PC. Now, what port are you going to use for the PC part? Actually, it's the console cable is a serial cable actually, right? But because we are no longer using the serial port, the COM1 port, nowadays we use the USB port, right? So there are cables that map to the USB port. So you can just plug into your USB port. Okay, but that is a special cable. I believe the ones we have in our lab, I checked earlier on, has that capability, right? So it's easy not to mess around with the COM1 port, COM port, communication port in the back. All right. So then you use that because you want to access, but you use the same terminal emulation software, but through the console cable, set your remote access, right? Set remote access for your router, and your switch. Of course, provide all the necessary password and encryption to protect, yeah, and then enable SSH so that when you are able to remotely connect to your switch, that means you're no longer using console cable, you'll be using the network connection, right? Network connection. And when you're using network connection, you will still use terminal emulator, but now it's running across the network, right? Okay, so just now we talk about doing backup and restore from TFTP flash drive, sorry, from the flash and the USB drive at the back, right? And then we talk about the password recovery, yeah, going into ROM mode, right? As it's booting up, you control back to go into ROM mode, and you tap that magic number, right, to switch into the mode that you can replace the password. And then after you set it, you switch back the mode, okay, in ROM mode as well, so that it's a way for you to recover, perform recovery if you forgot password, okay, to recover password. All right, so we go to the next section, which is iOS image management. All right, so this video will demonstrate the process of upgrading the iOS on a Cisco router. All right, so you guys can go to NetAcad now. So I'm not going to show this video because it's available on NetAcad. So please do check the video. In fact, the NetAcad, I already opened up all the chapter exams, right? So the moment you finish revising our slides, can go to NetAcad, finish revising the NetAcad, watch all the videos, try all the quizzes there, or the interactive questions as part of the materials. Then you can try the chapter exam, right? Try the chapter exam to test your knowledge, okay? So that at least you don't have to cram everything, okay? At the end of the semester, when you're doing your revision for your advanced component network, you don't have to rush everything, cram everything into such short time, right? You have to start from now already, yeah? So to help you along, I already opened up all the chapter exams, right? So you can try out the chapter exams on your own. It's not MCQ, right? As usual, and you can, I think, try multiple times. Okay, I think it's taken three times, right? All right, so here we are especially talking, this time we're talking about the running config, right? In the startup config. Yeah, so now we are looking at the Cisco iOS software image. Remember, when you type a directory at the bottom of the list, you actually see the file with the extension .bin, the bin, yeah, bin sounds binary basically, yeah. That is the image, Cisco image file, right? So it's very important to have a copy somewhere, just in case, right? You get corruption, right? And then so you can very quickly recover back your switch or router, okay? In terms of corruption to the Cisco iOS binary image file, right? So backup whenever you're operating, you're maintaining any device, and you have important software or data, you need to do backup lah. So the same here, okay, so that we can bring our device back online if there's any corruption. We should keep a copy of the Cisco iOS image, right? So here we want to use a central Tftp server to perform our backup, right? Okay, so not only to make sure we have a backup, we also need to do it every time we want to upgrade. So if there's anything wrong after the upgrade, you can always have the older version, right, to replace the new version back, right? Just in case, right? Just in case, so you have the older version that you know already working. If your upgrading didn't go as planned, right? Okay, so good practice to keep a backup copy. Yeah. Right. So routers, if you have only one router, it's quite easy lah. The Tftp server can be one of the machine that you trust to have the backup in. But it will become crucial if you have multiple routers. Okay, when you have multiple routers and their location are widespread, meaning to say they are not centrally located. Okay, so going around holding a USB flash drive to backup manually is actually not a efficient way to do the backup. So designate one server or one computer as the backup server, right? So you can download a TFTP server. So TFTP server basically is you can get any version, right? So you could just show you the example, right? We have here one TFTP server, right? Then you can have others, Solarwinds TFT server. You got free, US free. So you can see best TFTP, right? So many, right? So if you ask me which one the best, I'm not quite sure. You have to read the review and see pros and cons for each of the TFTP server. But TFTP server is there's a lot, just like the terminal emulator, right? So whichever you decide to use, okay, they're supposed to support the same protocol TFTP, so they are compatible, right? So install it into one of your trusted computer, right, and that becomes your TFTP server. And of course, you already specify, but during the configuration of your TFTP server, where if you send a file in, means you want to make a copy. This backup is actually making an off the device copy. That means into another device, right? Okay, so that means why we want to use that is because of the network capability rather than manually walking around physically accessing those routers backup manually to a USB drive, right? Okay. Right, to backup iOS to TFTP server, first test the connection. Make sure you can reach the TFTP server. Okay, so where your TFTP server is installed, not its IP address. IP address of that device. Could be a router, it could be a PC. So if it's a PC, also can, router also can. But usually we save it to a PC, right? So ping that TFTP server, make sure connectivity is good, right? And then go to your flash drive. Just now we show you how to view the content of the flash drive. Flash drive is the default, so you can straight away type dir to view content, right? So you want to see the file that was at the bottom of the list, which is the image file. You notice it by the extension .bin, right? Okay, so then you need to copy, right? The copy syntax is copy source URL, destination URL. So the source URL is the name of the file, destination URL is the IP address of the TFTP, right? So let's have a look at here. You can see copy TFTP. This one is restoring. Okay, so this is copy to a device, right? Or here I didn't see it, but this is the what lah. So that means copy the file name to TFTP, right? TFTP address. Oh, TFTP, and then it will ask you for the IP address. In this example, the IP address you're using is, of course, the IP version 6. It's okay, yeah? Can use also, no problem. Okay, IP version 4, IP version 6. As long, because the application layer is doesn't care which addressing you use, whether it's IP version 4 or IP version 6, right? So this is a reverse copy from TFTP to Flash. All right. So booting Okay, because this OS also, when you switch on your device or router, it will boot up, right? So during boot up, before it loads the OS, okay, the OS cannot load itself, right? So this is the conundrum of operating system. It cannot load itself. So you need some code to load the OS. Then the at least the kernel part of the OS is running. Then it can take over from there. So that piece of code that is used to load the operating system is called the bootstrap code, right? So before the OS is loaded, the bootstrap code runs, and what it does is passes the startup configuration that is inside your NVRAM, right? And then after that, then it will boot up your uh, OS lah. Then will boot up your iOS. But here you can see that there are some boot system commands in the configuration. So if you will manipulate the booting portion of your your system boot up, right? But that's beyond our syllabus. Okay, we don't learn about what else we can configure for the boot system, right? Just know that you can configure the booting process. Okay. All right. So I think this one also we've done already in our practical, right? So I'm gonna stop my recording now. So any question, everyone? Right?
No.
Yeah,
No.
we reached the end already. Okay. So the companion to this is last week's packet tracer exercise. Yeah. All right. Okay. So tomorrow we're going to look at revision, preparing for SBA. Next week also revision, preparing for SBA. Right. And in week 13 should be SBA. Yeah. Okay. Did I share with you guys already the timing?
I don't think so.
Or if not, then I will upload to our Google Classroom announcement, right? Similar to before, right? So, but it's not going to be until week 13, right? Week 13.
Oh, never mind. Yeah, I think I see it.
You saw it already. I shared already. Yeah. So basically, what we covered for SBA, right? What we've already done so far. Okay, so we'll talk about the SBA tomorrow lah, during practical. Okay, as I give you the SBA revision. All right. So let's have a look at the tutorial until VPN IP6 concept. Right. So tutorial 8. And yeah, only up to tutorial 8 now. Okay. So let me see. Our lecture slides only up to chapter 7 now. All right, so I will upload now. Okay. Alright, everyone, I've already uploaded the rest of the lecture up to now. Chapter 8, VPN IPsec concepts. Chapter 9, QoS concepts. Chapter 10, network management. Obviously, I really hope you do read the materials online also rather than ACAT, because the way they present it, there's a lot of opportunities for you to to gauge your understanding. They have lots of questions just to test your understanding. Also videos, right, to help you out, right? Okay, so I'm gonna update the tutorial now. Right, everyone. I already shared the tutorial 9. Okay, so you can do as homework, yeah?
Okay.
All right. So I think that's it for today. I'll see you guys tomorrow for practical.
Okay.
Okay, sir. Thank you.
All right, thank you.